Describe the function of a flowchart and how to construct one. Flowcharts are program design tools for mapping out the steps of a program visually. They assist the programmer in choosing instructions and designing programs for many types of applications. The flowchart is drawn from top to bottom in the sequence in which the program is to perform. The flowchart consists of special symbols that identify the type of operations the program will perform. Input-output. Input-output. The input-output symbol is used when the controller must address input or output devices. Process step. The process step symbol is used when the controller directs the movement of the robot or any non-input-output task. Decision. The decision symbol is used when the robot program jumps to a branch or performs a change in the process based on sensor information from the work cell. Connector. The connector symbol signifies that the chart continues on another page or at another point in the flowchart. Start-end. The start-end symbol indicates the beginning or end of the chart. Direction of flow. The direction of flow symbol is used to show the path of the process. A flowchart can be drawn based on the general sequence of operations for a robot application. For example, this general sequence might look like the graphic shown here. Move to a wait position. Wait for input to turn on. Get part from feeder. Place part on conveyor. Turn on conveyor. Wait for 5 seconds. Turn off conveyor. And repeat cycle. Construct a flowchart given a general sequence of operations. In this procedure, describe the function of conditional commands and give an advantage. The MCL language contains a number of useful program commands which can be used to help the programmer develop work cell control logic. Some of the most useful of these commands are the conditional branching commands. A conditional command causes the robot program to execute one command or set of commands if a certain condition exists, and another command or set of commands if that condition does not exist. In effect, the program branches in one of two directions. In this application, the robot places the part on conveyor 1 if PB1 is pressed, and it places the part on conveyor 2 if PB1 is not pressed. Note the difference between using conditional statements and using the wait-I command. With the wait-I command, the program will not do anything until that particular input is in the specified state. The program will stop at the wait-I command and wait. If conditional branching is used, the robot may be used to perform other tasks instead of waiting for an input to change. Describe the operation of the conditional commands if then, else, Endif, and Inp. The MCL language includes these conditional commands: if then, else, Endif, and Inp. The if-then command is used to conditionally execute one or more commands. The if statement is followed by a comparison. If the comparison is true, the program executes the command or commands that follow the then statement. An if-then command can be followed by more than one command. When this format is used, commands are executed until either an Endif command or an else command is encountered. The else command may be used after an if-then command. If the comparison in the if-then command is false, the commands following the else command are executed. Execution continues until an Endif command is encountered. The Endif command marks the end of the set of commands following an if-then command. Execution of commands following the Endif command is not affected by the comparison made in the if statement. The Endif command is not used when only one command follows the then statement. The Inp command allows the programmer to check the state of a specified input. This command can be used in the comparison of an if-then statement to conditionally execute commands based upon the status of an input. Here is one example of a simple if Inp then command. This command tells the program to look for input 3 to be on. If it is, then the program will branch to the label Go. The if Inp then command may also be followed by else and Endif statements. Examine the program to better understand how the if-then, Inp, else, and Endif commands are used together. In this example, the robot moves to point 1. It then checks to see if input 1 is on. If input 1 is on, the robot moves to point 2 and point 3. If input 1 is off, the robot will grasp, delay, and release. Branch Go is an unconditional branch that sends the program back to the beginning. The cycle repeats until the program is halted by the operator. Describe how robots are applied to multiple machine loading cells and give an advantage. The time it takes a robot to load a CNC machine is short compared with the run cycle of the CNC machine. This means the robot could have a lot of idle time while it waits for the CNC machine to finish its cycle. To increase efficiency by reducing this idle time, the robot may be used to load and unload more than one machine. After feeding the first machine, the robot receives a signal from another machine that is ready to receive a part. While the first machine is processing, the robot loads the second machine. When the first machine is finished, the robot unloads and then reloads it. The robot then retrieves the part from the second machine and reloads it. This type of application requires the use of conditional branching commands. The robot has to check to see if the first machine needs loading. If the first machine does not need loading, it checks to see if the next machine needs loading. If the second machine needs loading, the robot loads it. If the second machine does not need loading, the program jumps back to check the first machine. In this case, two if-then statements are needed in your robot program. After loading either machine 1 or machine 2, the flowchart shows that the program jumps to the location marked A. In the flowchart, A is where the conditional statement checks to see if PB1 is on. Using a marker such as A is an optional method instead of drawing continuous lines. Describe the function of a subroutine and give an advantage. Robot programs can become quite long and hard to follow. Many robot programming languages use a technique to simplify programs by breaking them into smaller, more manageable components called subroutines. A subroutine is a small program usually designed to perform a single task. There are two primary advantages to using subroutines. The program is easier to read, and the size of the program is reduced. One advantage of a subroutine is that it makes it easier to read a program because the major steps can be followed by reading the functions of the subroutines. Although the actual program may consist of hundreds of program lines, those lines can be grouped according to the tasks they perform. For example, each listing in this general sequence can be made into a subroutine which would contain all the program lines necessary to perform that task. Notice that some tasks are being performed more than once. For example, Tool 1 is picked up several times. The same subroutine can be used more than once in the program so that program lines are not repeated. This is accomplished by having a main program that can jump to the same routine many times. This program shows the format using subroutines. When this program is run, the first line executed is a jump to subroutine 1. This causes the program to jump to line 6 and execute the lines that follow until it reaches the end of the subroutine. At this point, the program jumps back to the main program and executes the next line of the main program. Notice that this program jumps to subroutine 1 2 times. This means it will execute lines 6 through 15 twice during its operation. The programmer determines which lines to put into the main program or subroutine. A general rule of thumb many programmers use is to write as much as possible into a subroutine, which leaves the main program brief. This enables modifications to be made in the main program by changing one line rather than several. Describe the operation of the subroutine commands call, return, and sub. The MCL language offers 3 commands to use for subroutines: the call command, the sub command, and the return command. The call command tells the program to jump to a subroutine. The name used with the call command indicates which subroutine is being called. The name can be up to 8 characters. The name can have a number in it as long as the name does not start with a number. These commands would tell the robot to jump to and perform the steps in the subroutine named Tool 1 or Subroutine A5. The return command is placed at the end of a subroutine. It tells the program that the subroutine is finished and to return to where the main program left off. Each subroutine must end with the return command. To better understand how these commands are used in a program, examine the program in this example. In this program, line 2 causes the robot to move to point 1. Then, line 3 causes the program to jump to line 8 to execute the subroutine. In this subroutine, the robot will grasp, delay, and release. Line 12 returns the program to line 4 to continue in the main program. Line 4 causes the robot to move to point 3. Line 5 calls for the repeat of subroutine hold position. After the subroutine is performed again, line 12 returns the program to line 6 in the main program. Line 6 moves the robot to point 5. Line 7 tells the robot to go to label start. The cycle would then repeat. A subroutine can be called any number of times in a program. It can also be called from within another subroutine. This is known as nesting. The MCL language permits up to 10 levels of nesting. Servo conveyor